Okay, so here we go, y'all. We're going to basically continue doing this. We're going to identify our a in this case. So in order to find our a, you're going to take the cube root of 1x cubed. The cube root of 1x cubed to find your a, that just gives you 1x, y'all. So I'm going to write it here. So I'm going to say my a is equal to x, and I strongly recommend identifying your a and b. If you can identify your a and b, that's like half credit. That lets me know you at least know what's going on here. Take the cube root of 125. Take the cube root of 125, and you end up with a 5. So you end up with 5 for our b. So let's just go ahead and plug this in. I have my 2 parentheses. That is no big deal. I have my plus, and this one is a minus, and then this one's a plus. See how I'm setting this up? If you did this, this is half credit. If you showed me what a actually was, showed me what b actually was, and you put it out like this, you know, it's just keep going. It's not as bad as you think. It's weird, but it's not that bad. So now we just follow the rules. A is x, b is 5, a squared is simply x squared. A times b is 5 and x. That goes together is 5x. And then plus b squared, which b squared is 25. Pretty straightforward. I'm going to go ahead and solve the next example as well. So the next example, take the cubed root of x cubed. So take the cubed root of x cubed, and that gives me x to the 1. Take the cube root of 27. Take the cube root of 27, and you end up with 3. So my a is x, and my b is 3. So how do I do this? Well, let's set up the skeleton. Let's get our things going here. We have that, we have our plus, and we have our plus. So now a minus b, x minus 3. A squared is x squared. And then a times b is 3x. And then b squared is 9. I can already hear some of y'all being like, oh my God, why do we have to do this? Yada, yada. Y'all, the reason why you have to do this, number one, it's state mandated. Number two, this is actually a good, it's not teaching you what you think it's teaching you. This is not actually teaching you the sum or difference of two cubes. Like, this is fine and dandy. This is neat math, but it has no bearing in like real world math, to be quite honest. You'll hardly ever use this stuff in the real world, but you will use cubes if you go into STEM, which I did quite a bit. You will use radicals. You will use square roots of stuff. You'll use a lot of different things. So, yeah, at the end of the day, you can think this is silly, but you're getting practice in literacy. You'll be able to, like, can you find the cube root of x cubed? Can you find the cube root of 125? Can you then plug it into here? So even though you feel that the entire product is useless, it's kind of like saying being on the treadmill is useless. Like, you're not going anywhere, but you did increase your cardio. And that's kind of how I feel about this stuff. You're not necessarily going anywhere in the real world with this, but you've exercised a lot of math skills to get here. So that's my little rant. I'm going to upload this video.